Okay, our next speaker is Wen Cabrel, who is a hardware design coding advocate. And the topic of Wen's talk is student attendance based on AB32VG1-RFID with a desktop IoT application. So I'd like to welcome Wen and hand over to him.
Okay, you got my screen, right?
Yep.
Okay. Good morning, ladies and gentlemen. It's an honor to have the opportunity to address such a distinguished audience. Let me start by saying a few words about my own background. My name is Wen Cabrel. I'm a senior engineer and further my research program in DAST, which stands for Distributed Acoustic Sensing. And I'm doing it at Zhejiang University in China. The focus of our presentation talk is students management system based on RFID plus a MCU named AB32GV1 with a desktop application. Our talk is particularly relevant to those of you who are questioning themselves on how to make a communication between a hardware design and desktop application. This talk is designed to act as a springboard for discussion. We have structured this presentation as follows. Briefly talk about some project we work on with an estimated time with 10 minutes, and deeply talk about the RFID plus the AB32 GV1 with a desktop application with an estimated time with 15 minutes. And then the remaining 5 minutes actually will be for the Q&As, designed for question and answer. Okay. Now, so as you can see on the screen, we have, we will talk about 3 projects that we work on. The first project is a tiny IoT with a ultrasonic sensor. And the secondly will be the load with the 485 bus. And the last one will be what I mentioned earlier. And if you have any question, you can reach me out at my email or my my Twitter account that you have the link just here. Okay, this is the overview of what I just said earlier, but let me just talk about it. We are going to talk about the DC electronic load based on the 485 bus. Briefly introduce, and then we are going to talk, I'm going to display the scheme and some parameters which help for the optimization. And secondly, the ultrasonic based on the STM32F working principle. We are going to talk about the working principle of the whole module and the scheme. And the last, we will deeply talk about the RFID with the MCU AB32GV1. And I'll quickly make a short video, which will be uploaded on the ASRI Shred YouTube channel, and then the team presentation. Next, this is the DC electronic load based on the 485. You might ask yourself, why this project? Why we design this kind of thing? Actually, we designed this kind of thing for maybe to charge some battery or any kind of device, and we want to set the voltage or the current to avoid the device, the electronic device actually to get damaged. So we have to control the voltage or the current. So the scheme of it works like this one. Here we have the DC electronic load with the keyboard and the displayer, as you saw earlier, and we have the controller. Actually, we use STC 8052, and then we set the current, the actual current, and the voltage is the power, or this part mainly used for the external device. Here this is to understand the process of how the whole system works. We have the displayer, as you can see here, and we have the key input, like you have to set which voltage actually the device, the electronic device, need to be loaded and so on. So we have the MCU here, we have the DC converter, we have the PMW to control the variation of the current and so on. So here we have the current detector. Of course, we have to check whether or not the current is high, or maybe if the device is actually full or not, as well as the voltage detection. So the final project looks like this one, and here we have if, for example, we want to improve the optimized actually our system, we would bring or add together some electronic components such as resistor, capacitor, and inductors, and also ROP. Then we put them together, and then we can be able to optimize the signal. And additionally, what you are seeing maybe some resistor here. Everything has been calculated in advance to avoid having like the device, the external device might be explode, or the battery might be explode. So this is all about this project. Now, the second project actually was based on the STM32F103. Actually, it's a tiny IoT system that we designed in our lab because we were tired, like tracking the distance of people during the pandemic or something like that, or maybe because this system can be also applied in the front door. When someone is there, the door will be open. So we designed this kind of thing. Actually, it has a ultrasonic sensor. As you can see, we have a buzzer, we have the LED here, and we have the GSM module actually who will send the data to an MQTT platform. As I said, it's a tiny IoT system. Let's talk about the scheme of it. As I said, we have the ultrasonic, which says the distance of people in front of the door, and then now sample it, and then we can save those data in the SID, or after we have sampled it, or either publish it through this SIM 800C, because we use this thing because actually the STM32 that we used was not able to, or maybe the board actually didn't have this module. So that's why we added an external GSM module for us to be connected to a MQTT server platform. And here is the LED to notice, for example, if you want to notice that, okay, something happened, we can just check the LED, or just hear the speaker, the sound of the speaker. So this is how the system, of course, works. Okay, next we are going to talk about one of our fantastic tools. The RFID plus our board blew through me based on the MCU name AB32VG1 chip. So we developed it through a ASUS Studio IDE, and then I'm going to talk about the scope. During this talk, we are going to talk about the concepts of the project, the environment, of course. If you don't set the environment, it will be difficult for you to achieve this one. And then we are going to talk about the different modules. We'll talk about the RFID concepts, the concept of the RFID itself. We are going to talk about the features, the data transmission, how we transmit data from the board, from to the computer, to our desk applications. And we are going to show you also the dashboard that we have made for both application and Windows phones application, and also some platform pictures. And then we are going at the end to do the review of the project. So let's start with our concept. Like I was saying, if you see here, can you hear me? If you can see here, for example, we have here the AB32 GV1 plus the RFID of itself here. And here we have the cloud, of course, because we would like to publish the data to the cloud. And then here we have our desk application. And here we have the student ID. The student ID actually looks like this one. We have two kind of variety. We have this kind. So for a worker or a student, they can have this kind of student RFID card, both with worker also. And here we have the database. And here we have the phone app. Actually, why is it important to have an external, a local database instead of publishing things online? We just realized that sometime we might have maybe the connections doesn't work well, it's difficult to access it. So we design an SD card on our router. We have an SD card where the data will be loaded into it, since the board itself can be attached to the front door, to the gate, or any door. So that's why we design an external database. And then we have the phone application where, for example, the admin or the CEO or whatever, the teacher can access and remotely and control what's going on, which teacher, which student has entered to the school, at what time, and so on. And here we have our desk application. We have our desk application here. We have our desk application here. This desk application is where actually we enroll student or worker. We fill every form and picture and so on. So this is how it works. Now, let's talk about the environment. As I said earlier, you cannot achieve this project if you didn't set well the environment. First of all, you have to install the AB32, the microcontroller itself, the MCU itself. You have to download that package from ASUS Studio. You have to download it. And then you have to enable actually some component, which is very important. As you can see, we have enabled actually we have enabled the GFS and the FATs for the SD card, and we have enabled the library, of course, because we download some external library patterns, sorry. And then, of course, the C++ because we write program in C. And now, about the driver, which is very interesting, since our projects carry a OLED, or let's say displayer, we enable the SPI connection to display yes or no, like you enter. And also we enable this serial port communication, which is very important in our case to make the transmission from our board to the this application. And we also enable the soft I2C for the RFID itself tag. So let's move on with. So this is how we have the MCU, the board itself. Then we make it without. Developing this module at that time, we weren't about that. We could have developed the desk application with Archithread. So nowadays it's possible, which means that Archithread is doing a wonderful job. Like they are not sleeping, they are moving very fast, which is very important for us developer, hardware developer. And it has been designed actually with an external platform named Visual Studio. And itself, it helps to enroll or to register some student or workers, or even the CEO itself, because he has to register. He has to if you want to access those data, actually he has to connect himself. And then secondly, we have the MCU, the AB32VG1 plus the RFID itself. It's an electronic device built around that chip, AB32 chip, which is connected to the RFID tag and has been developed through RFID Studio ID. And then we have the phone application, actually, which is very important because the admin can remotely control himself or herself, wherever the person is. He can connect and retrieve all the data, knows what is going on there. And when we have the RFID tag, which is very important, RFID tag actually is what we give to the student, and then or the worker, when they arrive in front of the door or the gate, they just place the card. So this is the different module that we have been developed. Okay, next. Now the main concept of the RFID is like, as you are saying, RFID can nowadays widely used. It's widely used nowadays. We use it for logistics, assessment management, access control, payment, product tracking, identification. In our case, we use the RFID for the access control and identification. First of all, this application, actually, we are going to identify student or workers, and then next we are going to make an access control by using that RFID. For the payment, it's more sophisticated. It's not like just using something or some library. It doesn't work like that. It's more complex. Now let's talk about the step of transmission. First of all, we need to collect the data. We need to identify which ID belongs to who. That's why we record, first of all, the ID, we enroll them, and then the second thing is we sample them. Sampling is the process of now encrypt those words or those frame which has been placed into this one, and encrypt it or decrypt it, and then or decode it, and then publish it to a cloud. which is here, as you can see here. Now let me share with you the desk application that we have made, actually, how it looks like. Here, as you can see, the desk application, actually, it comes with some features, with a dashboard. Its dashboard looks like this one. You have a connection, you have a user, and then you have a registration form. When you click on the registration form, actually, it shows like you have to fill this like name, address, city, and country, and then you have to add your picture and then upload it, and then it will display as here, as you can see it. Then when, for example, someone at the gate place, or when we have done with the registration part, when we want to test, when someone places the card, actually its card on the module, and then it will show all its the person information, as you can see here. Now let's talk about let me share with you the mobile application. Okay, the mobile application actually looks like this one. We have the admin, or someone who has received the authorization, can log in and then see what everything student enter, at what time, and so on. So this is how it looks like. You can connect yourself here. You connect yourself, and then you can access the database and so on. Now, let's talk about, let's review a little bit the important things about our concept. And let's a bit talk about the advantages of this project. It eliminates paperwork. It automatically samples data, fast and secure. It's unique, and it can be used on LAN or remote server. And the PC or the desk application, the concrete functionality. Our software contains a lot of functionality, and also each having specific operation to perform, and it's very efficient, and it has framework, and actually it can be installed in any kind of Windows, iOS, Windows application, or Windows operating system, and we have the phone application that I talk about it yearly. We have it. It will be a phone application which can be also downloaded from any other Android phone. We have the electronic device that we attach it on the front door, or we give it to the person actually who is going to register, because the project actually comes. The project actually comes in two parts. We have the one that we attach to the door, and then we have for the registration that we connect it to the computer, and then we give you the desk application software, because it's a X file. It comes with an X file, such as you can install it in your computer. So let me talk about something which is very important, and I really love about ArchiShred. This is the full of the ArchiShred. It's reliable. ArchiShred is reliable and efficient, and evaluation secure and flexible and oriented. What I really noticed with the improvement nowadays is like it gives you the ability to upload your own board. And for example, a company who like to would design his own board, and then he want to make it work with ArchiShred. He has to go on. He only needs to download actually the ArchiShred Studio, and then apply by himself. He doesn't now need a lot of process, and the application is very flexible. And also you can use a lot of variety of MCU there, like STM, and even Raspberry Pico, which is give the ability to people like us who are hardware designers to jump into it and have fun, play around with it. Team presentation. me, Wen Cabrel. I'm the one who will present this one. And thank you for your attention. If you have any question or after any question now or after this presentation, you can reach me out with my email address, as you can see, or follow me on Twitter, and then we can talk. Now, I'm going to share with you a small video that we have made. Oh, I don't know how to, if I have to share again the screen. Okay. Okay. I don't know if you can see my video. Can you see the video?
I'm not seeing it yet, Wen.
Okay. Well, maybe I have to share sharing and then wait, give me a bit. Okay, this video is very short, but the full one will be uploaded to the Alfred channels and maybe next week. Yeah. Okay. Oh, so the video is very short. So, which makes the end of my presentation. Now, for any question, I'm open for the Q&A question for everyone who has a question. Thank you for the opportunity.